Good day, everyone. We are Group 9 from CE22S10, and we will be presenting the experiment number 5. Objective. The activity aimed to introduce the basic principle, significance, and procedures in determining the unit weight and density of aggregates, particularly coarse and fine aggregates. Intended learning outcome. Familiarize the equipment, apparatus, and method in determining the unit weight and density, coarse and fine aggregates. Second, determine the difference between the rounded and loose unit weight of aggregates. Third, determine the importance of role of unit weight in the construction materials utilization.
For the discussion, unit weight or density is the relationship of aggregate's weight to its volume, expressed as weight per unit volume. Values of unit weight over density are used in volumetric to gravimetric calculation. In volumetric batching of concrete aggregates, the unit weight per density should be known to convert weight over mass into loose volume. For the resources that are going to be needed, a tamping rod which dimensions are 16 millimeters in diameter, 600 millimeters long, ay 2 pans, 1 weighing scale, 1 bag of fine aggregates, 1 bag of coarse aggregates, and 2 cylindrical metals, preferably provided with handles and sufficiently rigid.
For the procedure of coarse and fine aggregates, rounded unit weight determination, first is peel one third of the measure level and tamp 25 times evenly distributed over the surface. Second is peel two-thirds of the measure, then to overflowing. Each time the same procedure as in step 1 is repeated. In tamping the first layer, do not allow the rod to strike the bottom of the measure forcibly. In the tamping the second layer and last layer, use only enough force to cause the tamping rod to penetrate the previous layer aggregate. Third is strike off the excess aggregates with the tamping rod. Fourth is get the net weight or mass of aggregate in measure. Compute the unit ma- weight or mass by dividing the net worth weight mass over weight or mass by the volume of measure. Next, for loose unit weight determination, first is peel the volumetric measure to overflowing by means of a shovel or scoop. Second is discharge the aggregates from weight of about 50 millimeter from top of the measure. Exercise care to prevent segregation of the particle sizes. Third is level carefully surface of aggregate with a straight edge. Fourth is get the weight over mass of aggregate in measure. Compute the unit weight or mass by dividing the net weight or mass by the volume of measure. Please take note that the size of the sample shall be approximately 125 to 200% of the weight required to fill the measure and shall be handled with a manner to avoid segregation. Dry the sample of aggregate to essentially constant weight, preparable in an oven constant weight with a temperature of 110 positive degrees, a positive negative 5 degrees Celsius.
Data and result. For fine aggregates, there is rounded and loose. There is trial 1 and trial 2. For the mass weight, the estimated data is 17,945 and for trial 2 is 17,997. For the unit weight or density, it is also estimated, but the formula we can use to get this is weight of sample over the volume of container. For the average, you must add the trial 1 of mass weight over and unit weight density divided by 2 to get the 8,973.438. For the loose, there is also trial 1 and trial 2 and the estimated value for mass weight is 16,406 and 16,450 for trial 2. The unit weight density is also estimated. The average is 8,203.858 and for trial 2 is 8,225.860. For the weight of container is 2,162. It is also estimated. For the weight and mass of water is 247 and the volume of container is 9,568 grams per cc.
For this part of the collected data in course aggregate, it is based in the video reference provided by the instructor. Each trial from loose to rodded are given. The volume of container is 2,162 and we assume the weight or mass of water in course aggregate is 244.98. For getting the formula of the container, we add the weight of the container and the weight or mass of the container times 9.81, which is the gravity of the earth, then divided the unit of or weight of the container to get the volume of the container, which is 9,639. For example, the rodded trial 1 is said to be 17.132. Now, in getting the mass or weight, we subtract the trial 1 in rodded and the weight container, which is said to be 2,162. And the next, for getting the unit weight or density, we divide the unit weight or density of trial 1 in rodded, which is 14,970 by the volume of the container, which is 99,639. And to get the average in the data of course aggregate, we add the mass or weight by the unit weight or density, which is 1.553, and divide it by 2 for the total of 7,374.774. We also do this procedure in trial 1 of rodded and trial 1 and trial 2 of loose course aggregate. For the conclusion,
In this laboratory exercise, the group concluded that the unit weight can be used to calculate the concrete batch yield and air content. The unit weight of the concrete gives a very excellent estimate of the air content because air adds no weight to the concrete and simply occupies a volume. Rodded unit weight determination is a weight measurement for a certain volume of graded aggregates that is used to check aggregate uniformity and the process of proportioning the mix. Loose unit weight determination is the weight of an unconsolidated aggregate of a known volume. The group successfully achieved the objectives and learned how to determine the unit weight and density of aggregates. That's all. Thank you.